We are looking at the case of solving a differential equation of second order with variable coefficients by Frobenius method. So, we have already seen we were doing one example where a initial equation has two roots. One first root will give you one solution. Second root, when you look at the difference between these two roots are k1 and k2, and the difference will be an integer which is non-zero integer. So, we have given first solution. In this video we will give you a second solution, how to get the second solution. That we have already seen what kind of form it takes for the second solution. So, we will see, we'll proceed how to get those that second solution. So, this is your second solution. The solution is of this form. Y2 is some constant, arbitrary constant, times y1 log x and x power this k2. So, k2 is this. So, finally, you get this form. So, y2 is a times some arbitrary constant y1, which you already know. You already derived for k equal to k1, which is 1 log x plus x power k2 is minus 2, and you have a power series representation dn x power n, when dn's are arbitrary constants along with a. So, these are constants you have to find out by simply substituting into the equation. So, the equation is given here. So, that is x square y double dash. So, this is your equation. So, we will just substitute into this equation for y2. So, for y you replace this y2. So, you calculate your y2 of x. So, I will use black. So, y2 is a times y2 dash you calculate. So, you get y1x by x. So, that I am differentiated log x, okay, and then plus a log x y1 dash of x plus here. So, you simply differentiate once, that is n is from 0 to infinity dn x power n minus 2. Okay, so, if you differentiate, this is going to be n minus 2 times x power n minus 1. This is what you will get, because these are all because k2 is integer. So, once you differentiate, you will see that n equal to 0. So, you have, so I think you cannot do this. So, let us differentiate. So, if you look at this series, that is d0 x power minus 2 plus d1 x power minus 1 plus d0 d2 x power 0 plus d1 d3 x and so on. So, d4 x square and so on. Okay. So, you can differentiate as a two functions, okay, as if this is one function and the series is another function. So, you can write, so differentiate this one. So, you have x power minus 2. This will give me n is from 1 to infinity n into n dn x power n minus 1. Okay. And then plus, and keep the series as it is and differentiate the other part, that is x power minus 2. What is the derivative of 1 by x power x square? 1 by x square derivative is minus 3 by x cube, minus 2 by x cube. Okay. Minus 2 by x cube. So, you have a minus 2 by x cube. So, this is what is your y2 dash, and you have y2 double, you need y2 double dash. So, second derivative will be a by x square y1 x plus a by x y1 dash of x. So, I differentiated this term one more time. Now, we do the second term. So, you have a by x y1 dash of x plus a log x y1 double dash of x plus, again this will give you, so one more derivative here. So, if you do that x minus 2, and this is from n is from 2 to infinity n into n minus 1 dn x power n minus 2. So, I differentiated the series first, I have to differentiate x power minus of, that will give me minus 2 by 3, 2 by x cube, where this n is from 1 to infinity, and dn x power n minus 1. Okay. And then now you differentiate the last term, so that will give you minus 2 by x cube. If you differentiate this series, then it's from 1 to infinity, and dn x power n minus 1. And then you differentiate 2 by x cube, that will give me, so derivative of 1 by x cube. 1 by x cube derivative is actually x power 5, right? So you have 3 x power 4, I guess. You get x power 4, right? So you have, this is x power 6, x cube is derivative minus, so you have 3x squared, so minus 3 by x power 4. Okay. That's why you have minus 3 into 2, so you have 6 by x power 4. So you have minus minus plus, so it's going to be plus, and you have this n is from 0 to infinity dn x power n. So this is what is your y2 double dash. Now substitute this y2 here, y2 dash and y2 double dash. Substitute into the equation. Given equation is, if you substitute, so you have x square into y double dash. First of all, first term is x square into y double dash, x square y double dash. So if you multiply, you need this x square. So I multiply here itself, it's x square, y double dash will be, you remove x square here, and you have a x here, x goes, and you have a x here, a by x, so x into a, and you have a x square, and this goes, and here you have simply x. Okay, and then here again x, and here x square. So you will get x square y double dash. So second term is x 2x plus x square y dash. So that is my second term of the given differential equation. So this, if you do, so for this you need x y dash, x y2 dash, and x square y2 dash. So let me do, so let me rewrite again. So you have x y2 dash of x is, from y2 dash you can get it as a y1 a x log x y1 dash of x plus x power minus 1 sigma n is from 1 to infinity, and dn x power n minus 1 minus 2 by x square sigma n is from 0 to infinity dn x power n. And this is my x y2 y dash. So you need 2x y dash, so multiply 2, so it will be 4. So this is what you have. So what else you need? So x square y2 dash. Now you multiply x square to this y2 dash, so it will give you, that will give you ax y1x plus ax square log x y1 dash x plus, you get simply the series and dn x power n minus 1 minus 2 by x sigma n is from 0 to infinity dn x power n. So these are the three things you have to substitute. So these three, and then for y into the equation. So given equation is x square y double dash plus x. So if you want a solution y2, so x2 y double dash x into 2 plus x, that is 2x plus x square into y2 dash minus 2 times y1 y2 has to be. So this is the given equation. Okay, in the given equation you substitute y2 dash and y2 dash, y2 double dash and y2, okay, from all that. So x square x square y double dash is, so you take this one and bring it here. So, this substitute here the whole thing if you replace. So, what do you get? So, you get minus a, let us do meticulously. So, y1x plus x a y1 dash. So, you have a 2x a y1 dash of x. So, second and third term together is that plus x square ax square log x. Okay. So, ax square log x y1 double dash of x plus, and this is as it is, you have n is from 0 to infinity n into n minus 1 dn x power n minus 2 by x, n is from 1 to infinity n dn x power n minus 1. So, this is my x square y2 dash, y2 double dash. Now, you add these two. So, this 2x y2 dash, that also if you add, so basically I am adding these two. So, 2x y2 dash plus x square, if you add it. So, if you can see that 2ax log x, if there are some common terms you can add it. Okay. So, if it is not, maybe you have to rewrite everything as it is. So, let me write. So, you have 2a y1x plus 2ax log x y1 dash x. y1 is the series solution, first series solution which we already obtained. Okay. 2 times x inverse n is 1 to infinity n dn x power n minus 1 minus 4 by x square, n is from 0 to infinity dn x power n. That is my 2x y2 dash plus x square y dash, that also you add ax y1x ax square log x y1 dash x plus sigma n is from 1 to infinity n dn x power n minus 1 minus 2 by x, n is from 0 to infinity dn x power n, and then minus 2 into y2. So, what is your y2? y2 is the form which you chosen, a y1 log x, that one. Okay. So, 2 into a y1x log x minus 2 x power minus 2 sigma n is from 0 to infinity dn x power n. That is what is the form. Okay. This one x power n. So, n is from 0 to infinity. So, dn, this is equal to minus 2 times of that is 0. So, this is what is your expression. Once you substitute y2 dash y2 double dash into this given equation, this is what you got. Now, you can easily observe, the coefficient of log x. What is the coefficient of log x? If you see the coefficient of log x, a log x for example, a log x is the coefficient. You take a log x out, you see the coefficient, what do you have? So, x square y1 double dash of x. Okay. So, this term I have taken. And where else you have? So, you have here. So, this will give me 2x y1 dash of x, and then here this will give me plus x square y1 dash of x, and finally here. So, this is going to be minus 2 y1 of x, but I know that this is 0. So, y1 is actually said, this is actually the exact equation. This together, if you see this together, this is the actual equation. So, original equation is, this is actually given equation satisfied by y1. So, this we know that this is actually equal to 0. Okay. So, because of that, these 3 terms will be 0, these 4 terms. Okay. That is what is this, that is what you have done now. Now, what else is left? What is left here is minus a y1, okay, minus a y1. So, you can write minus a y1 of x, and then 2 x a y1 dash. Is there any other thing? Yeah, there's nothing, so you have to write it. So 2x a y1 dash of x, and then 2a y1, 2a y1 and minus a y1, so that's going to be plus. Okay, so this together will give me only a y1, so that's I have written here, and you have written this part here. Now what is left is ax y1, so that this together ax y1, so you have ax y1 of x. Okay, and this one, now you write all the series, remaining series. Okay, so what is the remaining series? So take these two, all these 6 terms, okay, 6, 7 terms. So if you write this, n is from 2 to infinity, n into n minus 1 dn x power n minus 2 minus 2 by x, n is from 1 to infinity, n dn x power n minus 1 plus 2 by x, n is from 1 to infinity, n dn x power n minus 1. So this is actually, this is also cancelled. Okay, so 2 by x, n dn x power n minus 1, n is from 1 to infinity. So this one, this will go, so I don't have to write. Okay, so this I have written, these two gone, now these two. So if you look at this, you have minus 4 by x square sigma n is from 0 to infinity dn x power n plus sigma n is from 1 to infinity n dn x power n minus 1 minus 2 by x, n is from 0 to infinity dn x power n, and then you have 2 by x square dn x power n, 2 by, so minus 2 by x square minus, that is going to be 6. So these two together, so this one and this one, you put it together, that's going to be minus 6, I have written here, and these two as it is here, so that is equal to 0. So this is what we have. So anyway, this has gone, so what is left is only this part. So this is the equation now. Now you know what is y1. So y1 is a series, you know, y1 dash, y, so you can rewrite and substitute your y1 here as a series. See, so remaining parts are all series. You substitute here and you will be able to find, once you get a series, you replace y1 as a series, you will see the once y1 you replace with the series, which you know as a first solution, and you will get all the terms 1, 2, 3, 4, 5, 6, 7 terms. Among the 7 terms in the equations, you have last 4 terms are series, first 3 terms if you replace y1 as a series, y1 is a series solution. So you calculate y1 dash, substitute in the first 3 terms, you will see that 7 series together equal to 0. So now that you expand and make the coefficients of each of these coefficients of x power n 0, that will determine all the unknown coefficients, which are a and dn's. Okay, so we can see that. So what is your y1? For that you need y1. So what is the y1 you got? That is x into, so this is what is your y1. So y1 is x minus x power x square by 4. So your y1 is x minus x square by 4, x cube by 4, 5, like that. Okay, so we will see exactly. So we will calculate that y1. So what is your y1? y1 is y1x, since y1x is given as x minus x square by 4 plus x cube by 4, 5 minus x power 4 by 4, 5, 6, and then plus x power 5 by 4, 5, 6, 7, and so on. This will go on like this. This is your series solution which you got from the first solution. Okay, so this is this one. So once you get this y1, so you need to substitute here. So for that you need y1 dash. So you calculate y1 dash of x. So that will give me 1 minus x by 2 minus 3x by 3x square by 4, 5 minus 4x cube by 5, 6, 4 you can get, 4 goes, and then plus 5x power 4, 4, 5, 6, 7 and so on. Okay, this is these two is try to substitute there into the equation. So now if you substitute a times ax minus ax square by 4, ax cube by 4 5 minus ax power 4 by 4 5 6 plus ax power 5 by 4 5 6 7 and so on. Okay, so this is my first term a into y1x. This is your a into y1x that I substituted now. Now plus 2xa 2ax into y dash. So 2ax into y dash, y1 dash is 2ax. So you are just multiplying 2ax to your y1 dash. 2ax minus 2ax square by 2 minus 6 x cube 6ax cube by 4 5. Okay, 2ax, that's going to be x cube. So minus, so this is plus, right? This is plus. So differentiate. So 1 plus minus plus minus. So you have this is plus, and now minus 2ax 2ax power 4 by 5 6 plus 2 is 10. So 10 x power 5 2ax divided by 4 5 6 7 and so on. So that is your second term. The third term is ax y1 dash x. So you are multiplying ax to y1. So that will give me ax square minus ax cube by 4 plus ax power 4 by 4 5 ax power 5 by 4 5 6 plus ax power 6 by 4 5 6 7 and so on. Okay, so these are the three terms. Now I wrote it as a series. This also you can expand. So even these series terms also you can now expand and write it as a full series. So if you write that, so you will get this series. If you write n equal to 2, so you will get 2 times n equal to 2. If you put 2 d2, that's 0, plus n equal to 3, 6 d2, 6 d3 x plus n equal to 4, 12 d4 x square. So I will write 4 terms. Okay, 5, n equal to 5, that will give me 20 d5 x cube and so on. If required, you can add it later here. Okay, so that is my this term, this series. So the next one is minus 6 by x square. N equals, so d is d0 n equal to 0. Okay, and then minus 6 by x square n equal to 1 will give me d1, that's going to be x. So that x, this x goes, so 6 by x. Again minus 6 by x square, so you have d2. This x square and d2 x square will go, so will give me minus 6 d2 and then minus 6 x d3 minus 6 x square d4 and so on. Like that you get the second one. Third one will be, third term you can see that n equal to 1. So d1 plus n equal to 2, 2d2 2d2x plus 3d3 x square plus 4d4 x cube and so on. Finally, last term 2 by minus 2 by x d0 minus 2 by x d1 x, so that xx goes, okay. So you have minus 2 d1, so minus 2 by x d2 x square, so that is going to be x minus 2 d2 x square, so minus 2 d3 x square minus 2 d4 x cube and so on, okay, all the way minus. And n equal to 4, you have minus 2 by x d4 x4, so that xx goes x cube and so on. So this is what I replaced all the series, I expanded them, this is actually equal to 0. So these are all since y1 and y2 are solutions, y1 is a solution and you already know that y2 is also going to be solution. These are absolutely and uniformly continuous in the domain where it is defined, okay. So this I have given without proof. These are uniformly convergent, so that you can add term by term and you can so you can put it together, okay. So that is why I am able to add all these series together. Now we simply get the coefficient of lowest terms, okay. So what is the lowest coefficient here? So first series nothing, only starts from x, second series also starts from x, third is also like that, the fourth one is also like that, the fifth one is minus 6 by x square. So you have a x power minus 2 coefficient, pick up the coefficient, okay. So coefficient of x, you make it 0, 0. What is the reason? So I have coefficient of x power, so c minus 2, x minus 2, c minus 2, or rather I put it c minus 2, I put it here, okay, x minus 1 and so on. So c0x plus c1x c1x plus c2x square, like that I am going to put equal to 0. So these are c1, c minus 1, c0, c1, c2, these are all the coefficients of x power minus 2, x power minus 1, so on. So if like this, if you have a series equal to 0, each of these coefficients have to be 0, that is what I am making it equal to 0. Coefficient of x2, that is here c minus 2, which is 0, which I am calling simply whatever, okay. I am seeing what the c minus 2 is, that I have only minus 6 d naught, okay, is equal to 0. So there is no such thing, that is the coefficient of x power minus 2, that has to be 0. So that immediately gives me d naught is 0, okay. And similarly coefficient of x power minus 1, make it 0. So this will give me, what is that you have? So 1 by x minus 6 d1, and what is the other one? So minus 2 d naught equal to 0. This will give me, I already know that d naught is 0, that will give me d1 is also 0, okay. And then make the coefficient of 0 is 0, coefficient of x power 0 is 0, that will make me, that will, what do you give? So what do you get? Constant term. Where is the constant term in each of the series? In all these 7 series terms. So you have 2d2 minus 6d2, okay. So I have here 6d2, 2d2, 6d2, okay. So I may not write anything here, so it's plus d1. So d1, which is already 0, equal to 0. So d1 is already 0, so d2 is again, so minus 4 d2 is 0, that will also go to make it d2 0. So now look at the coefficient of x1 equal to 0. This will give me, what is the coefficient of 1, that is a plus 2a, so that is going to be 3a, and then you have 6d3 minus 6d3, so it is going to be 0, so that I do not have anything, and here plus d2, that is also 0, so that will give me a equal to 0. So you are seeing only 0 solution, something is wrong. So y2 is satisfying this, so when we substitute this y2 double dash and y2 dash and y2 into this equation, what we had missed is these two terms. So when you have this x square y2 double dash, I added only this part, so this remaining you can add here now. So you have minus 2 by x, n is from 1 to infinity, n dn x power n minus 1 plus 6 by x square, n is from 0 to infinity dn x power n. So, this is my x square y2 dash, y2 double dash, and then 2x y2 dash is these 4 terms, and then x square y2 dash is these 4 terms, and then minus 2y is these 2 terms 0 0. So, as usual, so you can remove this y, since y1 is satisfying these 3 terms together, these 4 terms whatever I cancel is actually giving me, because satisfying the, is the first solution satisfies the given equation, so that will make it 0. So, what you have is this, and I have 2 more. So, these 2 terms are required. So, these are extra. So, this is not just this. So, you have to add minus 2 by x, n is from 1 to infinity n dn x power n minus 1 plus 6 by x square, n is from 0 to infinity dn x power n, which is equal to, so now this is what is equal to 0. So, when you are adding this equal to 0, so let me add these 2 terms which I missed earlier. So, this is 1. So, the first term, so what you have is, so the last term which I missed, this if you write it also, you have a minus 2 by x. So, let me see if they are common to anywhere. So, you have, they are not common. So, you have 6 dn square dn. So, this will go, these 2 terms will go. So, I do not have to write the second term. Okay. So, you have 1 2 3 1 2 3 4 fifth series you do not have to write. So, 1 2 3 4 5. So, this part is actually not required, because they get cancelled with the last one. Okay. So, this series is getting cancelled with the last one. So, only you have to add this term, so which I missed, minus 2 by x n dn. So, minus 2 by x. Okay. So, you have minus 2 by x, n equal to 0, n equal to 1, that will give me d1. So, 2 by x d1 minus 2 by x, and then you have n equal to 2, you get 2 d2 x, 2 d2 x minus 2 by x 3 d3 x square minus 2 by x 4 d4 x cube, and so on. So, that is what is equal to 0. So, I have now 1 2 3 4 5 6 7 series which are 0. So, you have 3 terms here, 4 5 6 7. Okay. These 2 series gets cancelled. So, now make the coefficients of x power minus 2 0. So, what you will get? You will get x power coefficient of x power minus 2 is 0. Will give me, this will give me d naught is 0. Okay, let me see what you have, x power, this is what you will get, this gets cancelled. So, you have x power a y1, so y1 2x x square this. So, you have, there is no x power minus 2 term, right. So, everything is powers of maximum minus x, x power minus 1. So, this here x goes, okay, minus 2 by x this, so it is going to be 4 d2. Similarly, here if you remove this x, this is going to be x, if you remove this is going to be x square, and so on. So, you have 1 by x term. So, you have maximum, lowest term is x power c minus 1. So, this term is not there. So, this is how your series is going to be. So, all these 7 series if you add up is going to be starting from x power minus 1, that is the first term, and then and so on, x power 0 next term and so on. So, you have make x power minus 1 coefficient 0, then what you get is, so what is the coefficient of this? You get minus d naught plus minus d1, which has to be 0. So, that will give me d naught equal to minus d1. Okay. So, d naught equal to minus d1, and then coefficient of x is 0. So, this will give me 2d2. So, what is your coefficient of, so constant, that is 2d2 plus d1 and then minus 2d1 minus 4d2, which is equal to 0. So, this will give me, if you add it, this is going to be minus 2d2 minus d1, which is equal to 0. So, you can write d2 as 1 by minus 1 by 2 d1. Okay. And now make the coefficient of x square, coefficient of x power 0 here. So, coefficient of x power 1, that is coefficient of x is 0. That is going to be, what is the coefficient of x? A plus 2a. So, first 2 will give me a plus 2a is 3a. Okay. So, these are the two terms, and then 6d3, here you get 6d3, 2d2, and then minus 2d2, and then here again minus 6d3 equal to 0. So, that will give me 63 goes, 2d2 goes, 3a equal to 0, that will give me a equal to 0. So, immediately once a is 0, the coefficient of log x for your second order equation, second solution, a is 0. So, you will not have log term. Okay. So, only x power minus 2 or d naught onwards it will be there. Okay. So, d naught is arbitrary. Okay. So, d naught is, you are not able to get it, right. So, d naught is given in terms of d1, d2. So, that you can put it, so like d1 equal to, so this will give me, this is actually like d1 is minus d naught. So, that will give me, what is d1? d1 is minus d naught, means this you can write in terms of, so it is going to be half d naught, d2. Okay. So, d2 is minus half d1, d1 is minus d naught. So, that will make it this one. So, you could get d naught, d1, d2 in terms of d naught. D naught is arbitrary. So, like that you can go on. I calculate one more, make it equal to 0. So, coefficient of x square, if you make it equal to 0, you have to, if you do meticulously, you should not go wrong. You will get everything properly. So, you get minus a by 4. A is anyway I found coefficient of. So, I do not have to, wherever a is there, now I can simply, now I found a is 0, I can simply remove this and you need not consider, because a is 0. Okay. So, a is 0, I need not worry anymore here. Okay. So, I have to take coefficient of x square. Coefficient of x square is 12d4 and then plus 3d3 minus 2d3 from here, and here minus 8d4 equal to 0. So, that will give me 12 minus 8, 4d4 and plus d3 equal to 0. So, that will give me d4 equal to minus d3 by 4. Okay. So, what is d3? d3 is arbitrary now. Okay. d3 and d naught both are arbitrary. That is what you are seeing. Okay. I could not get d3. So, let me calculate one more term. So, coefficient of x cube equal to 0. If you make it, what happens? See, you get something, you get most of the, sometimes you will get all the coefficients except one, or you may get, see, if you look at this form of the second equation, second solution. Okay. Where is your second solution? So, this is in this form. Either I may get all these constants a and dn's, so that you know what exactly what is your y2, or rather a dn's, a and dn's are all, you will be able to find all these constants in terms of one constant. Okay. So, that means you calculate all of them except one, but you write everything else in terms of one constant. That means, so that constant comes out and some power series. Okay. that way you will get it. So, that is the once you take the whatever the arbitrary constant will be, that you can take it as 1, that will, so the once you take that as arbitrary constant 1, that will be the solution. That way you can get, or if you sometimes you may end up getting all the solutions, some solutions in terms of one arbitrary constant, some solutions in terms of some other arbitrary constant. For example, in this case when a is 0, that is what is I am getting. Okay. So, if you see this, a I got 0 and D1, D2 are given in terms of D0, D4 in terms of D3, because D3 I could not find, that means D3 is arbitrary. Now, if you make it coefficient of x cube is 0 from these 3. So, if you look at this 20 D5, okay, so and then what you have, so this is going to be x cube is 4 D4 and then 4 is minus 2 D4. And what about here? So, this is going to be coefficient of so what you get is one more term is actually here minus 2 by x 5d5 x cube, okay, 5d5 x power 4. So, that is going to be x cube with removing this. So, you have 2 5 and so on. So, you have minus 10 d5, okay, that is what you get equal to 0. So, this will give me 10 d5 plus 2 d4 equal to 0. So, this will give me d5 as 1 by 5 minus 1 by 5 d4, and d4 is given in terms of minus d3. So, it is going to be plus d3. So, you have d3 by 4 5, okay, and so on you will get it. So, like this you are getting. So, what you are getting is finally is y2 of x, which is given as a into log x, a y1 x into log x. So, a is 0, a I found to be 0. So, that is going to be, that term will not be there, and you have x power minus 2. So, d0 is I did not find. So, d0 I did not find. So, d0 plus d1, d1 is minus d0 x, okay. What is d2? Plus half d0, that is my d2 x square, okay. These are all given in terms of d0 plus remainings are d3, I could not find d3 x cube, and d4 minus d4 is minus d3 by 4 x power 4. What is d5? d5 is d3 by 4 5 x power 5 and so on. So, you can expect next one will be minus d3 by 4 5 6 x power 6, okay, like that you can expect. So, what you got finally, this is equal to d0 times, so 1 by x square, take this x power minus 2 inside, you get minus 1 by x plus 1 by 2. So, this is your solution. So, this is your d0 into this plus, now if you do this, this is going to be d3 comes out as constant, this is going to be x minus x square, if you take this x square by 4 and then you have plus x cube by 4 5, okay, and then minus x power 4 by 4 5 6 and so on. So, what is this? This you already know, this is exactly your y1 of x, okay. So, you got, sometimes you may get your solution, second solution in terms of something else, your y2 plus y1, okay, like here. So, I do not need this y1 because I already got my y1, okay. So, so this itself is second linearly independent solution. First of all, if you do not want this form and you already have y1, you take whatever, if y1 is part of solution into your second solution y2, you can remove it, you can split it and remove it. So, this is my y1, I do not want that. So, you take it d3 as 0 and d0 is arbitrary, that you take it as 1. So, that you get your second solution y2 as 1 by x square minus 1 by x plus half. So, this is your second linearly independent solution. This is also linearly independent solution, it is like y1x. So, I got some y2 of x, so some function here. So, this is your say your y2x y2x plus some arbitrary constant d3 times y1 of x. This is also a solution. These are two linearly independent solutions because y1 and y2 are two linearly independent solutions. Okay. You can see that this part and this part are two linearly independent solutions. This I already know, so you can remove it. So this is your second linearly independent solution. Or here itself you can say this whole thing together. You can consider d naught equal to 1 and d3 as also 1. You can also say that this is a series solution which is also linearly independent solution. Okay. If you take d3 as 1, this is going to be like this. This is a series solution. I have some only 3 terms as a solution plus already known solution together. This is your y1 and y1 plus y2 as two linearly independent solutions. So you can also say this are y1x and y2x. These are two linearly independent solutions. Here I removed this y1. Okay, that is why it is only y1 and y2. If you do not remove your y1, so it is going to be both are series solutions. That is how you get. Okay. So this is how you can solve any second order differential equation when the initial equation have as two roots and the difference is integer, okay, non-zero integer. So here in this particular case you have seen first root is 1, first root is bigger root is 1, that will give you the series solution. Second solution we have chosen in a certain form when the difference is non-integer, non-zero non-integer. Okay. So difference between the roots k1 minus k2, k1 is bigger root. Okay. So when k1 minus k2 is non-zero, non-integer, when it is integer, sorry, it is a non-zero integer. Okay. This is the case for non-zero integer. So the bigger root will give me one series solution. Second solution in certain form when the difference between these two roots k1 minus k2 is non-zero integer, which is k1 is 1 and k2 is minus 2. So the difference is 3, which is integer, which is non-zero. In this case we have chosen special form for y2 and substitute to the equation, get the unknowns. So what we find is the second solution is actually simpler form 1 by x square minus 1 by x plus half. Okay. So this is how we can get any second order equation when the initial equation has roots and root difference is non-zero integer. Okay. So you can just meticulously follow the same method, you can find any equation when in this particular case. Now we look at the another case. Now we have only one more case is left. Okay, that we will see in the next video. That we consider an equation whose initial roots, when you find the initial roots, roots are same. So that means the difference between the roots is 0 but integer. Okay, so that is away from the case 1 and case 2. So this is a case 3. You have actually equal roots. Equal roots, one will always give me first bigger root. Let us say bigger roots both are same. So bigger root will give me one solution, one series solution, and you have to find a second linearly independent solution in a special form, which I explained earlier as a case 3. So we will demonstrate with an example in the next video.